Hello and welcome. In this presentation we will be looking at perpetuities and how they are implemented using recurrence relations. Now, perpetuity is an investment in which the payment made to the investor equals the interest earned. Therefore, the perpetuity maintains its value forever. So, in terms of our recurrence relation, it will increase due to an interest calculation and decrease due to our repayment. If these two values match, then we have a perpetuity. So, consider the situation with Susanna. She invests $1,000 at a compounding interest rate of 5% per annum to set up a perpetuity. Right. There is regular ongoing repayment of $50 per year. So, what will happen here? She starts with $1,000. That will earn $50 interest each year. And she will withdraw that $50 interest, maintaining the balance of the perpetuity at $1,000. And this will go on forever. It's very important to note that the payment received by Susanna equals the interest that has been obtained by the actual fund. So, let's look at perhaps a more realistic situation. Now, Susanna creates a perpetuity to honour each year's best maths student. She invests $50,000 into an annuity at 6% per annum. Calculate how much each award recipient will receive. Now it's fairly, basically the D, the repayment, is equivalent to how much interest has been earned. So we basically just need to make these two sides of the equation balance. So D will equal R divided by 100, so the interest rate is 6%, and I just need to multiply that by 50,000. So effectively, 6% of 50,000 is 3,000. So she will, basically an award will go out and sue out Susanna's name, in which a student will receive $3,000. Each year it'll be a different student. That's basically the nuts and bolts of the perpetuity. Now, sure, we can do this mathematically with a little bit of algebra, or we can use our calculator. And again, what you'll notice here, we actually have 1 month, one payment I should say, and our payment per year is 1, because we're only looking at our interest rate of just 6%. There's no compounding here, just 6%, just like simple interest. She's going to invest 50,000, so a negative 50,000, and at the end of the perpetuity, basically in forever, there will be $50,000 left, which she would be able to withdraw. Right, interest rate 6%. Leave this field blank and then hit enter, and what we'll end up is demonstrating that we end up with $3,000 as our payment, our regular payment. Notice it's positive to indicate that the money is going to the recipient of the award. Now, let's looking at a past paper question. The year's 2012, Further Maths, it's exam 2. Now, Arthur invests $80,000 in a perpetuity that returns $1,260 per quarter. Interest is calculated quarterly. calculate the annual interest rate of Arthur's investment. So, here we go. I could use my TI-Nspire, or I could use a little bit of algebra. I was just looking to see whether I actually had the algebra. I haven't got that, so we'll just go straight to the TI-Nspire. What you will notice here, going to receive $12.60 per quarter, so that's the payment, and it will be positive. Arthur deposited $80,000 into his perpetuity, so we'll have a negative $80,000 because the money has flown from Arthur to the perpetuity. At the end, which will be basically never, there will be $80,000 for him to, or whoever, to withdraw. Now, interest is calculated quarterly, so I need to have 4 payments per year, and there's only one. We're only really interested in the next payment. Leave this one blank, then hit enter, and you will end up with 6.3%. It's probably the simplest way to actually solve this question. We could go through the algebra and basically have 80,000 because my V0 equals R over 100, and D has to be equal to 1260. We would solve that, and then we need to take into account the fact that we're dealing quarterly. So, and part B, okay, of this question is very, very common sort of question. After Arthur has received 20 quarterly repayments, how much remains invested in the perpetuity? Well, I think I've mentioned this a few times, but the answer is forever. ... He will always have $80,000 in that perpetuity. So, getting a little bit sore in the voice, made a few videos today. I hope these videos have been of assistance to you. So until next time, good maths and bye for now.